Hi guys, we are going to do a worksheet called Counting Atoms. Okay, I'm going to get you started just to help you kind of review. Okay, so this sheet is all about chemical formulas and practicing what they mean when you read them. Okay, so the top, I did this part for you just to remind you of how this all works. So there are parts to chemical formulas. The symbols. Okay, again, this is why I took off points when we were back in school doing stuff. The chemical symbols or the elemental symbols are important because it's one capital letter or a capital letter followed by a lowercase, okay, and that lets you know the different elements in the compound, okay? So if you notice, the first one here is done for you. Na is the symbol for sodium. And then I know the O is a different one. It's oxygen, and then the H is hydrogen. So here we're just writing down what they have, okay? Notice how there are no numbers here. So that takes us up to letter B here. The subscripts are the numbers that are found on the lower right-hand corner next to a symbol, okay? Notice the term sub, like as in a submarine. It is under. Okay, so another example over here, H2O. This is a subscript. Okay, tells you how many of each of the atoms are in that compound. Okay, so again, and if a symbol has no subscript next to it, it's kind of assumed that there's a 1 there. It's sort of like when you write X in algebra. Okay, so in one molecule of water, there are 2 hydrogens and 1 oxygen. Okay. That will help you do the first 7, okay? As you go on, there's some brackets, but let's do a couple of these so that we can figure out how this works, okay? I'm going to do HNO3, which is nitric oxide. I think it's nitric oxide. So the H is for hydrogen. Okay, there is no number next to it, so that means there's 1. Nitrogen is the N. Again, there's no number, so that's assumed to be a 1. And then there are 3 oxygens. Okay, because the subscript is 3. This subscript only goes with the oxygen. So in one molecule, or one molecule of this compound, there are 5 atoms. Okay? Let me take a little aside to bonding, just so we can see where we're going. Okay? And this is a good one to actually, let me do a different one. Okay? Because it'll just make a whole lot more sense. I'm going to pick this third one. Li is lithium. There's a 2 next to it. Oxygen. There's assumed to be a 1. Okay? So, if you guys go back, let me flip colors so you can actually see. L-I-O, and it's Li2O. Okay? Now, if I do a Lewis dot structure for lithium, right? It is in group 1, I believe. Now I feel like I need a periodic table. Hang on, let me find one. I think there's one in the back of this book. Perfect. Okay. Lithium, right here. Group 1, 1 valence shell, electron. So its Lewis structure looks like this. Yeah? 1 valence electron. And I have 2 of them. Okay? Oxygen, okay, has 6 valence electrons. Looks like that. Okay? If you notice, there's a parking spot open here, as I like to call it, and a parking spot open here. So what's going to happen is this valence electron is going to march up here, and this one's going to march up here, okay? And then the molecule will actually look like this. Okay? That's kind of bonding, all right? So that's just kind of a look ahead and why we're doing this. All right, back to letter C here. Some molecules are more complicated than others, and so there are brackets. So if you look down here, I did this one for you. It's MgOH2, and there's brackets here, or parentheses, okay? So the brackets that surround groups of atoms, okay, indicate that how many of that group travels together. So this OH thing, okay, is, it's kind of like it's an ion. It's a polyatomic ion is the fancy word. And the O and the H travel together, okay? So when it bonds with magnesium, I need two of them to fill the magnesium's outer shell, or magnesium needs two of these to give its electrons to more accurately, okay? So all of the atoms inside the bracket are multiplied by the subscript on the outside of the bracket, okay? So here we go. I did magnesium here, or I did this one for you. So we have magnesium. There's no number next to it, so it's assumed to be a 1, okay? Let me move my camera down so you can actually see. Then this O and this H are inside the bracket. There is a 2 next to the bracket. So that means there's 2 oxygens and 2 hydrogens. So there are 5 atoms in each of these elements. Sorry, mom moment right there. Little unsafe activity. All right, so where was I? So the O and the H travel together. There are 2 of them. So 2 oxygens, 2 hydrogens. So that means in each molecule of this compound, there are 5 atoms. Okay, let's go over here and do this one. AlOH3. Okay, again, actually, let me do this one. So Al is aluminum. Okay, there's no number next to it, so it's assumed to be 1. The O and the H travel together. Okay, and the 3 next here goes through the whole thing. So let's say 3 and 3, so that's 6, 7. So in each molecule of that element, or that compound, there are 7 atoms, okay? If I go down here for 1 second to say number 15, okay, I have Al, there's 2 of them because there's a subscript, okay? This SO3 thing travels together as a pack, okay? So this 3 goes to each of the elements. So there are 3 sulfurs, but 3 times 3 is 9 oxygens. Make sense? So there's 14 atoms in that one molecule. Okay? All right, finish the worksheet. I don't care if you do your answers on a piece of paper and take a picture, or you can type them in DocHub, whatever works for you. I just want to make sure that you understand, or that you try, remember this is graded on effort, to complete this worksheet. Okay? I want to make sure that you understand what chemical formulas are. Have a good day, guys. Miss you.